Here's the easy way to graph sinusoidals. So a lot of times you'll be given some sort of sine or cosine function, such as this one. Now I know there are a lot of numbers, but here's a quick trick to make graphing it easy. The first step when graphing is to find the center line, which is equal to whatever the number is being added or subtracted at the end of the function. In this case, it's +1, so we're going to draw a dashed line at y equals +1. The next step is to find the min and the max of the function, which is the center line plus or minus the amplitude. To find the amplitude, just look for whatever number is in front multiplying and make it positive. In this case, our amplitude is 3, which gives us a max line 3 units up at y equals 4, and a minimum 3 units down at y equals -2. Don't worry about labeling what the tick marks on the x-axis are. That's coming up next. Now for the hard part. Usually your teacher will have you memorize some weird equation that uses the period and then tries to combine it with a phase shift. But honestly, this sucks and is hard to remember. The easier way to do this is by using quarter points to find our x values. Here our first step is to find our starting and ending points by setting whatever is inside the parentheses equal to 0, and then setting it equal to 2 pi. Doing some algebra, this gets us pi over 12 for our first starting point and 9 pi over 12 for the ending point. Don't worry about reducing fractions just yet. Trust, it's going to make things a lot easier. The next step is to find the midpoint between our starting and ending point, which if it isn't easy to see, is also just the average of these 2 points. You can find the average by adding the 2 points together and dividing by 2. Here we add 1 pi over 12 to 9 pi over 12 to get 10 pi over 12, which dividing by 2 gets us 5 pi over 12. Once we have our midpoint, now we find our quarter points, which are halfway between the midpoint and either the starting point or the ending point. Let's use our averaging trick again. For the first quarter point, we get 1 pi over 12 plus 5 pi over 12 equals 6 pi over 12, divided by 2 for 3 pi over 12. And for the third quarter point, we get 5 pi over 12 plus 9 pi over 12 equals 14 pi over 12, divided by 2 for 7 pi over 12. Now that we know all our x value quarter points are multiples of pi over 12, we can choose that to be our tick mark scale and start labeling the x-axis. The final step is to calculate the y values for each of the special x values. One surefire way to do this would be to plug each x value back into the original function and solve. However, here's an even faster way that requires way less algebra. If we remember from before, to find the x value for the starting point, we set whatever was inside the parentheses equal to 0. So for this point, we already know that the sign will be doing the sign of 0, which is just 0. So now we see that the y value is just equal to 1 at the starting point, x equals pi over 12, which will also be the same for the ending point, x equals 9 pi over 12. This is because sine and cosine repeat themselves every 2 pi. Now remember that the midpoint was halfway in between the beginning and the end. So whatever was inside the parentheses would also be equal to halfway between 0 and 2 pi, which is just 1 pi. So now since the sign will be doing the sign of 1 pi, we know that this is equal to 0, which figuring out the rest of the equation just gives us 1. So the y value at x equals 5 pi over 12 is also equal to 1. Now for the first quarter point, what's inside the parentheses is halfway between 0 and pi, which would be pi over 2. Since the sign of pi over 2 is 1, this means our y value is -3 times 1 plus 1, which equals -2. For the third quarter point, what's inside the parentheses is halfway between pi and 2 pi, which would be 3 pi over 2. Since the sign of 3 pi over 2 is -1, this means our y value is -3 times -1 plus 1, which equals +4. Note that this follows a pattern where whatever the result of the sign part is will oscillate from 0 to 1 to 0 to -1 and back to 0. There's a similar pattern for cosine, except this is shifted so that it goes from 1 to 0 to -1 to 0 and back to 1. Keep these in mind if you want to save even more time. The final step is to plot the points and reduce any fractions on the x-axis as much as possible, and you're done. And there you have it. That's how to graph sinusoidals.
Nice!